Director at Manar Al Omran. Joining me today is Cameron, our operations manager. Before we begin the live demonstration, I would like briefly introduce our company. Manar Al Omran has more than 45 years experience in scaffolding. We manufacture a wide range of scaffolding products and provide a complete scaffolding solution to the market. We're proud to be approved by Aramco and support a major industrial client through the scaffolding related services including material supply, delivery, design, engineering support and skilled manpower.
Thank you, Omar. Today's session is designed to give the audience a practical comparison between three scaffolding systems: Cuplock, Ringlock and tube and fittings. Our main live focus today is the erection of the Ringlock system, while we also discuss the major technical and operational differences between all three systems.
As Operations Director, the responsibility is to ensure that our scaffolding operations deliver the right balance of safety, productivity, manpower efficiency, execution quality, and operational control. The choice of scaffolding system does not affect erection only. It also affects planning, workforce utilization, supervision, efficiency, project timing, and overall performance.
And then from my side, as operations manager, I focus more directly on field execution, how efficiently the crews work, how the systems perform during erection, and how components are handled, and how practical each system is under actual site conditions.
So while the audience is watching the live Ringlock erection, we will also be discussing the technical operation differences between the three systems. Once the film is completed, we will be publish the full comparison covering the erection and removal of Cuplock, Ringlock, tube and fitting.
In today's demonstration, we are comparing three bird cages. The Cuplock dimensions are 7.5 meters by 7.5 meters with a platform height of 4.2 meters. The Ringlock dimensions are 7.71 meters by 7.71 meters with platform height of 4.2 meters. The tube and fitting dimensions are 7.5 by 7.5 and a platform height of 4.2 meters. Our live online demonstration today is focused on the erection of the Ringlock system. At the same time, the full activities for all three systems are being filmed, including both erection and dismantling. That complete recorded material will be shared later.
So we will go for transparency. The comparison is being conducted under the same conditions of each system. We are using the same number of men with the same skilled level for all the three systems, including 5 scaffolders for each system. This helps to ensure that the comparison reflects the performance of the systems themselves rather than the differences in the cross size and capability.
Exactly. Keeping the manpower level consistent allows us to compare the systems more objectively in terms of erection speed, labor efficiency, handling and workflow performance.
Right. Cameron, before we move into the live erection, could you briefly explain the difference between the three systems?
Of course. Tube and fittings is a traditional scaffolding system. It offers high flexibility, but it usually requires more loose components, more manual connections and greater labor skill level and effort. Cuplock is a modular system that performs efficiently in standard and repetitive configurations. Ringlock is a modular system that offers strong performance in connection efficiency, erection speed, adaptability and site practicality. From both a technical and operational point of view, Ringlock often provides one of the best balances between speed, flexibility and structural organization.
Right. Thank you, Cameron. We will now move into the live scaffolding erection phase.
Start. You may start. Yes.
Okay. Okay, Cameron, as the work progresses, I will guide the discussion from the operational side and Cameron will walk through the technical observation.
And just as a reminder, the live demonstration today is focused on Ringlock erection only. The full filming for all three systems, including erection and dismantling, will be shared afterwards.
Okay, Cameron, as the crew starts, what's the first technical point the audience should pay attention to?
If we just wait, pause for a brief moment, we'll allow the team to get to a certain phase of the erection, and then I'll be able to share with you some observations.
Yes.
As I turn my head round. Right. The first difference we can see is at the base. Ringlock uses separate base collars to ease the erection process. The next noticeable difference is at the connection point. Ringlock uses a captive wedge system compared to the cup connection with Cuplock, and tube and fittings use numerous different fittings. Ringlock is based on standards with fixed rosette connection points, which allow horizontals and diagonals to be connected quickly and consistently. Compared with tube and fittings, this reduces connection complexity because crews do not need to position and tighten as many separate couplers. This directly improves erection speed and helps create a more controlled installation sequence.
And from the operational perspective, this matters because the system shows effective project timing, manpower productivity, supervision, and overall operational control. Let's just stay with the live erection for a moment so everyone can observe the crew's base and coordination.
Are we off?
Let's go upside down.
So we've got 10 minutes now. So I think, because we don't know if the microphone is on or not. What the fuck is Rashid doing? I can't look.
Okay. That's good. Continue.
No, we've got 10 minutes. So it's 13 minutes. So if we wait for a bit, let's have a little look what the next section is. I don't know if the camera's on it.
Cameron, from a manpower utilization point of view, what stands out when we compare a system like the Ringlock under the crew condition?
When the same number of scaffolders is used across all systems, the difference becomes easier to see in how effectively that manpower is converted into progress. With Ringlock, the crew achieves greater progress as all of the levelling is done at the base. The erection thereafter can concentrate solely on assembly. No need for further adjustments or handling of separate loose connection items. This is one of the reasons the productivity profile of this system is often stronger.
Okay, and that directly matters to the operation because manpower utilization means better productivity, better planning, confidence, and more efficient to the resource on site.
Yeah. At this stage, it's useful to watch how quickly each connection is completed and how little interruption there is between one step and the next.
Another thing is that important for us operationally is mainly handling the material handling for sure. Cameron, how does the ring lock compare in terms of material flow and handling practically?
Material handling is a major factor in real site performance. When a system uses a more organized modular arrangement, crews can generally manage components more efficiently. There is usually less confusion, better sequencing of material movement, and more control over what is being installed next. Compared with tube and fittings especially, Ringlock reduces dependence on a high number of separate loose items, which helps the workflow remain cleaner and more manageable.
Right. That has a direct effect on the site organization, housekeeping and movement efficiency around the work area. Cameron, if someone watching today is familiar mainly with the tube and fitting, what practical differences should be noticed in the ring lock erection?
The most visible difference is usually in the simplicity of the connection process and the reduction in handling steps. With tube and fittings, crews typically spend more time positioning tubes, aligning them, leveling them, and tightening individual couplers. With Ringlock, the system logic is more integrated. That helps reduce repeated manual steps and supports a faster, more organized erection sequence.
All right. So what the audience is seeing is not only a structural difference, but also a workforce difference.
Exactly. And in actual projects, workflow efficiency often becomes one of the biggest decision-making factors.
Okay.
Again, if you focus again on the connection points of the ring lock, you'll see that this tells a lot about the speed and the logic of the system.
Right. Okay, and when we compare the ring lock with Cuplock, how would you explain the difference?
Cuplock is a strong modular system and performs efficiently in many standard repetitive applications. Where Ringlock often stands out is in the balance between modular speed and application flexibility. Ringlock has the potential to fit up to 8 connection points at any node point. All 8 of these can be individually secured. Cuplock requires a cup to be fully loosened to access any one of the only 4 possible connections. So while both systems are efficient, Ringlock can offer additional versatility in many project conditions while still maintaining very competitive erection performance.
Right. Which means that from an operational point of view, the decision is not only about speed, but also about how adaptable the system remains under the different site demands.
Exactly right.
All right. One point I always look at is how easy a system is to supervise and control during execution. Cameron, what's your point of view on that with Ringlock?
Ringlock supports supervision well because the assembly pattern is more structured and visually easier to follow. When connection locations are predetermined and the erection logic is consistent, supervisors can monitor progress more clearly, identify issues faster, and maintain better control over execution quality. This is especially valuable in industrial environments where both productivity and compliance matter.
And that's where operational confidence increases. When the system supports not only erection speed, but also strong oversight and readability.
True.
We'll pause the discussion for a moment and let you continue observing the erection progress directly. Let's also touch on safety and execution discipline. Cameron, how does a system like a ring lock support better discipline during erection?
A structured modular system helps create a more repeatable erection sequence, and that repeatability supports better execution discipline. When crews are working with a clear connection logic and a more organized assembly path, it becomes easier to maintain consistency in how the work is carried out. Of course, safe performance always depends on trained manpower and proper supervision, but system design plays an important supporting role.
Right, and this is why, for us, system choice is always connected to both productivity and controlled safe execution. From a client point of view, the real question is always, what value does this create on the project? So, Cameron, how would you answer this practical terms?
Practically, the value comes from a combination of factors: faster erection, better manpower efficiency, improved workflow, and more organized material handling, and stronger execution control. When those benefits come together, the system can contribute to better schedule performance and more efficient site operations overall.
That's exactly how we evaluate it operationally. The right system should support not only assembly, but also a project performance as a whole.
We'll give the audience a moment to continue watching the live progress before we move to the final technical summary.
They are reaching right now. Okay. Direction is going to be opposite. Where did they reach in direction?
Not yet. I'll tap you when we go to the next bit. We're boarding out now, so it's going to be very loud. One of the major differences you'll notice between the Ringlock and the Cuplock,
Yes.
the Ringlock uses a board as a beam. It does not require separate transoms underneath.
Right.
So you'll notice when they board out now,
Yes.
it's a very fast process compared to both the Cuplock and the tube and fittings.
Yes.
Both Cuplock and tube and fittings require additional transoms, additional fittings to secure them. This is not needed with the Ringlock system.
We are brushing there. A few minutes to go.
Generally, when you compare the initial stages of Ringlock and Cuplock to the untrained eye, it may seem like they're very similar rates of erection. And this is true generally up to the frame stage.
Okay.
But what we find with the Ringlock is when you come to the added benefit of the system, the fact that the steel board itself is a beam, the fact that the braces themselves fit directly to the rosettes,
Okay.
no need for additional fittings, then you'll start to see the Ringlock start to accelerate away in progress. The Cuplock again is still a great system, but the less components that we have with Ringlock is why you generate and you see the overall efficiency and progress.
As we are approaching the latter stage of erection, what final observation would you ask the audience to notice, Cameron?
I would ask them to take notice of the overall consistency of the erection process. Not just the speed, but the continuity, how the work sequence progresses, how the crew handles the components, and how the system supports organized assembly from stage to stage. The overall consistency is one of the strongest indicators of the operational efficiency.
Right. And from a leadership perspective, consistency is what gives you confidence in planning, execution, and surface
This is true.
delivery, right? So just as a reminder to everyone joining us today, live session is focused on the Ringlock erection demonstration.
And after this session, we will share the complete filmed comparison showing the erection and dismantling of Cuplock, Ringlock and tube and fittings in full.
Yes. Cameron, if you had to summarize the comparison technically, how would you describe it?
I would summarize it this way. Tube and fittings offers traditional flexibility but generally requires more labor input, more skilled labor and more component handling and more erection time. Cuplock provides modular efficiency and works well in standard, repetitive applications. Ringlock provides a strong overall combination of fast assembly, efficient connection design, labor productivity, structural organization, and a wide application versatility. This is why Ringlock is increasingly preferred in many modern project environments.
Right.
What we'll see now is what I indicated at the earlier stage. When we first started erecting the Cuplock and the Ringlock, you would see that the frame pretty much progressed at the same speed. But when we get to this stage now, you will notice that Ringlock has all the braces in from the first lift. The Cuplock has all the braces in. But Ringlock, we have already finished all of the boarding and they're moving on now to hand railing, followed by topping out and the next lift. If we look at Cuplock, they're still at the boarding out stage. This is the benefit that the Ringlock steel board system gives us from an efficiency standpoint compared to the other two systems.
And from an operational leadership perspective, that matters because the right scaffolding system affects not only a field execution, but also planning efficiency, workforce utilization, surface quality, and overall project performance. This is one of the reasons we believe that comparison is valuable for clients and project teams.
Again, if we compare and we take a look over my right shoulder, we'll see that the tube and coupler is the slowest of the three systems. It requires a very high technical skill level. None of the node points are already marked out. Everything needs to be measured and leveled and checked. So whilst we've compared the three systems, we already have Ringlock have moved into the topping out phase for the second lift. The Cuplock are starting to put the ladder and the first areas of handrail in place. And we'll let you enjoy the progress now.
Yes. This progress will go about, this progress will go about 5 to 10 minutes remaining.
I literally can't hear you.
No? Too fast?
Just sit.
We'll let them watching the video right now, yes.
Again, Omar, if you can see behind us,
Yes.
Ringlock has already moved on now to placing the ledges for the second lift.
Yes.
All of the toppers have been put in place, so the final height of the legs have already been finished. Again, if we see that in comparison to Cuplock, again, the strength of the steel board is obvious. Cuplock is still at the stage where they have to individually fix with board retaining clamps every board. The steel Ringlock board has an integrated locking mechanism that doesn't require this process to take place. And obviously, if we look at the tube and fittings, they're still at the basing out stage. You're halfway.
Yeah. Halfway. We will let the audience watching and let them.
Well, I'm hoping the camera's not on us. When we compare the bracing of the two systems, you'll see that like the ledgers, the ring-lock diagonals, they have the same connection point as the ledger, which is a captive wedge. This doesn't require separate fittings. Again, with Cuplock, they use a tube and two fittings. So this helps in the faster erection times.
Can we explain, Cameron, the stages where they are reaching right now?
Pretty much the same or further progress as before. The base lift boarding and ledgers and bracing has been finished. They put the first lift handrails in place. They're finishing up the second lift ledgers, and they have started to place some of the steel boards. And again, if we look back to tube and coupler, they're starting to fit some of the last remaining standards. Cuplock, again, we are still on the boarding and handrail stage.
And what about the Cuplock, Cameron? You just explained the Cuplock. What about the tube and fitting?
Yeah, well, the tube and fitting boys, they've got all of their standards in place now, just finalising that off. The next thing they'll have to do is they'll have to individually fit double couplers, right angle couplers, to put their ledgers in. Each one requires a separate fitting. Each one requires individually leveling, which takes a lot of time and skill.
Yes. Very much clear and obvious right now. Okay.
So the ring-lock fitting the final ledgers in place for the second lift, and has started the boarding out. I think it's obvious to see when you actually start boarding one of the main advantages of the ring-lock system.
Yes.
Now they're fitting the braces, and as described before, you'll see that each brace is a set size and has the wedge, captive wedge, on each end. No need for separate fittings. And it's literally as easy as that, then a couple of strikes with a hammer and the diagonal brace is in place. Another added benefit for the ring-lock system, the steel boards we're using are 2.57 meters in length, and they have a width of 32 centimeters. So therefore, for a scaffold width of 2.57, we can use 6 boards and a 19 centimeter wide board. So for argument's sake, each bay has 7 separate steel boards. If we compare that to the tube and coupler scaffold and also the Cuplock scaffold, tube and coupler requires 10 boards, so that's 3 more boards that need to be handled because they're only a width of 225 millimeters. With Cuplock, it requires 9 additional boards. So again, this is another time saving. The steel boards themselves have an overall width of nearly 10 centimeters wider per board.
Where they did reach now, Cameron? Where they are reaching right now?
Again, continuing to finish off the second lift, I would say they're probably 60% towards completion.
Yes.
And again, possibly the tube and coupler guys, I would say they've probably completed about 15%. So just on this live demonstration, I would estimate that Ringlock is displaying it is 4 times faster than the tube and coupler on display today. When we look at the Cuplock, I would estimate at this stage that it's twice as fast as what the progress that we see at the moment. It'll be interesting to see once we finally finish how it actually ends up. But this is what we see in practical terms. In this live demonstration, generally Ringlock in this application tends to be 4 times faster than tube and coupler, and we tend to see up to twice as fast as Cuplock, depending on the application. Now we see the Ringlock team have moved on to the installation of the first to second lift ladder, and getting to the stage where they're almost completed all of the steel decking to the second lift. And again, in comparison to the tube and coupler boys have started to fix the double couplers to enable them to put the first lift in place. And the Cuplock team are continuing the boarding. The boarding is a very laborious process. Each wooden plank, 4 meters long, 225 millimeters wide, requires 2 board retaining clamps, 1 at each end. This is not required with the Ringlock system because of the self-locking mechanism.
Right, right.
Another interesting, Mr. Omar, is the steel boards, the steel toe boards that come with the ring-lock system. Again, both the tube and coupler and the Cuplock, they use the standard wooden scaffolding board, which requires board retaining clamps or single couplers to hold it to the standards.
Yes.
You'll see here that they've just finished fitting the L-shaped steel toe boards. They interlock together. They don't require any fittings at all. So it's literally a one-piece operation.
That's a major difference right now.
Yes. Again, a major difference in material handling, speed of erection, also storage and loss of components.
Yes.
You don't need to do.
Yes.
Now we're moving on to the handrail phase of the final lift in this example. The team will fit a double guardrail and toe boards, and that will complete the birdcage. Again, we look at the other two systems. The tube and coupler guys have started to put their ledges in place, which will all individually need leveling in both directions. The Cuplock boys, can't really tell, but still going with the boarding. They have a single lower guardrail in place. And again, you'll notice with the ring lock, the ledges, even at 2.57 meters long, one individual can put them in place.
Okay.
Again, when you compare it to the tube and coupler,
Yes.
we need at least 2 scaffolders to erect, at least 2. Passing up the final guardrails. Now you can see how lightweight the toe boards are. Steel, fully galvanized toe boards, no additional fittings required. A very elegant design, they slot into each other. Now we'll probably see quite a rapid end to the completion of this scaffolding. Most of the equipment has been passed up now. Very easily the final toe board's going up. Very lightweight, yet still incredibly strong.
Yes. one guy can lift the steel board by himself. So there's a major difference.
Of course, yes. And also, the way it's designed, the L shape, they stack into each other. So they take up a very small amount of space with either transport or site storage.
Right.
Which is also a useful benefit.
Right. That's a major benefit if we compare it with the Cuplock right now.
I think, I mean, what might be interesting, and I'm sure we'll do it for the final video, is we'll give you a shot of all the components before we started erecting, and obviously all the components after we dismantle, and you'll see the sheer volume in difference between the number of components compared for ring lock, Cuplock, and tube and Cuplock. If you watch the chart, literally, it's that quick. Then the other one will slot in place and hold it. You'll see him lift the two together, slot them together, and that's it. As simple as that when you fit the toe boards. It's got the final two pieces of handrail going in now. The lower rail first, the mid rail, followed by the top rail. It just looks like a bit of toe boarding to finish. Obviously they're turning around the self-locking latches on the steel boards. I think it's demonstrably faster. Again, as we said before, we will share the full video of you. We've seen the completion of both Cuplock and tube and coupler. And later on today, we will film the dismantle of all three systems as well.
Absolutely.
And we will time that.
Absolutely. And it will be shared afterwards.
Yes. Again, they're coming to the final stages.
Yes. So they're already reaching the final stages, and we are looking at the minute. How many minutes exactly, Cameron?
Well, so far they're 46 minutes they've taken. In my experience, for structures such as this, anything under an hour is acceptable, and we've found repeatedly that this structure can be built by pretty much all skill levels in under 1 hour. Obviously, in this example for the live feed, it's an impressive time.
It
is an impressive time.
46 meters and 46 minutes after, just below the hour. So that sounds that is impressive.
And it's less fatigue on the workers. It means obviously if you plan and you supervise your work correctly, it means that if you use a ring lock system, when you think of oil and gas and the amount of reactive nature of the work there, when you respond to this reactive work, there are less materials you need to move. You can get whatever's broken, whether it be a valve, whether it be live plant, as a customer or a client, as a subcontractor, as a provider to those people, you can provide a better, more fast, efficient service. I think they're the final finishing up now, tying off the ladder, top and bottom. And they're coming down now. Just ensuring that every single steel board has the locking mechanism in place. just to be completely fair, the tube and coupler and the Cuplock scaffolding, they have to have board retaining clamps. We have steel board retaining clamps built into the board. It's only fair that we close all of them. It's a definite like-for-like comparison.
Yes.
Unfortunately, this phase is very loud.
Yes.
Yes.
That is
a
loud.
lot of hammering. Yes.
And I see them going down now.
Yeah. Well, as they progress down, the top of the lift is finished. They're now securing all of the latch locking mechanisms for the steel boards. And basically, once that is done, the scaffold is finished. So we have a full 7.71 meter by 7.71 meter by 4.2 meters high, both lifts fully boarded, both lifts fully guardrailed, both lifts fully tow boarded, provided with safe access, with ladders tied top and bottom, exactly the same as we will produce for Cuplock and eventually the tube and coupler. Looks like they finished up securing the boards on the top lift. Just checking they've got them all in place. And now they're coming down to do the same on the base lift.
And thank you everyone for joining us today. We hope this session has given you a clear understanding of the differences between the Cuplock, Ringlock and tube and fitting, while also showing a practical and operational value of the Ringlock system.
And once again, please look out for the full recorded release, where we will share the complete erection and dismantling footage for all three systems. Thank you for your time, and we look forward to your questions and feedback. I'd like to take this opportunity now to introduce you to two of my further colleagues, yes. Dr. Mohammed Salah and Engineer Ehab, who would like a moment of your time. Thank you for your attention.
Thank you for your attention. Thank you very much.
Dr. Salah, Engineer Ehab.
Thank you. As we see here, the rate for erection for Ringlock now coming around 52 minutes. The cubic meters, it's around 7.71 by 7.71. The height is 5.2 meters, which around 309 cubic meters. If we erect this in 52 minutes, that means by 5 scaffolders, the rate per one scaffolders, it's around 65 to 69 cubic meters per scaffolders per hour, which is a very fantastic rate for the scaffolders, which reflect, of course, for other items, as Mr. Ehab will say.
Thank you, Dr. Salah. So with the amazing numbers that we've seen ourselves and the amazing numbers that you just mentioned, as we all know, when we're talking about savings between the Ringlock and the Cuplock, it's obvious that we have a saving in material approximately that ranges between 20 to 25% or even 25% to 30% in terms of material per cubic meter, of course. When it comes to the manpower, as we've seen in the actual demonstration, in fact, we're talking about saving between 40 to 50% in terms of manpower. And as we are all aware that the cost of a scaffold, to build a scaffold, the manpower constitutes approximately 80 to 85% of the cost of erection of a scaffold versus 15 to 20% in material cost. So when we're talking about saving 40 to 50%, Dr. Salah, 40 to 50% in terms of manpower versus the 25 to 30% as well in terms of material cost. So obviously we're talking about a saving, approximate saving on the cost of erection of a scaffold, approximately 50%, which is a tremendous number that alone by itself, it's a no-brainer to go directly for the application of a ring-lock system versus the Cuplock system.
Yeah, thank you, Mr. Riyab. Really, the number is very fantastic. We invite you to continue with us for the final comparison between the three systems. Also, we will add the dismantle in the cost also with the erection. Finally, you can compare what is the difference between three systems. And thank you to join us in this.
And as we're aware, we have our technical team in the background. They're ready to answer any question, any technical question that you might have. Thank you very much. Thank you.
Thank you.